Okay, we're calling this a tree trellising trial, but basically the story behind it is that we know how productive the most productive orchards are currently. We know where the fruit, on what sort of structures the fruit are produced on, and what we've got to try and do is find a way to maximise the number of those structures on trees for the future. So what we're trying to do is explore ways of increasing the number of spurs, and that's the structure we're talking about, by investigating different training techniques. And one way we can do that is to try and alter the natural structure of the tree such that it produces multiple leaders. A tree's natural structure is just to send a shoot skyward, and then everything else sort of hangs off that. We're trying to send multiple shoots skyward, and all those shoots coming off the sides will be producing spurs, and that's what we need to do. We need to produce about 9,000 spurs per metre of tree row if you like, on a two-dimensional fruiting space, and that's the kind of structure we're looking at for the future. So as we do that, as we go into a two-dimensional fruiting space and we have multiple leaders, we might have some idea of how many spurs are actually possible. The other bit of the equation is how close can we put those rows together, and at the moment these rows are about 5 metres apart. That's based on the equipment that we've got, you know, the ease with which we can use that equipment between trees. In the future, that consideration won't be there. There'll be newer machines invented and designed so forth to cater for those closer plantings. But for the moment, for us, it's really how many spurs can we get on a tree? What's biologically possible, if you like, using alternative training techniques. And those alternative training techniques will alter the relationship between the shoot tip, which is what happens when you have a central leader just going skyward. We will alter that by pushing that central leader down and let multiple leaders come off that. So we have a horizontal cordon, if you like, and then multiple leaders coming off. And with that, we expect that we'll be able to improve the number of spurs on a tree. We don't know if that's going to meet the performance criteria we've identified, 9,000 per lineal metre of row, or not, but this is what this trial will actually establish that. We've also done multiple densities, so we don't know whether if we improve the number of spurs per metre of row, whether that a single root system or multiple root systems are going to be required to drive all of that, and that's what the density comes into it. So in the background here we see trees that are 1/2 metre apart, and they will have 2 vertical leaders coming off a horizontal cordon. There are other ones where we are 2 metres apart and they will have 8 coming off. So that gets kind of busy. We don't know whether that root system will be able to alter that. We also know that those root systems that are underneath the rootstock, and there are multiple rootstocks in here, imparting different levels of vigour, whether they will actually alter the relationship between the growing tip and the rest of the tree or not. And that's the tree architecture essentially, and that's another question we're trying to answer here. Now we have all the posts in here because we know it's going to be a true 2D fruiting structure. The surface area that will present to wind will be quite large, and that the possibility of wind just simply knocking that over means that we're going to have to train these things onto wires and simply to hold that structure up, and that's why there's some fairly heavy engineering, over-engineered certainly, and that's what you see here, over-engineered. We do that because it's pretty hard to go back and retrofit. Let's over-engineer now, and we can come back and say in the future, yeah, we're a bit heavy-handed, we could have saved a bit of money, but if it falls over, it's too late.